Okay guys, today we are going to talk about thermal conduction and thermal conductivity, and also about coefficient of thermal conductivity. Okay, so first of all, what is thermal conduction? Thermal conduction is the transfer of internal energy by microscopic collisions of particles and movement of electrons within a body. Okay, chu nge niang omje chu thermal conduction kan ti chu energy, internal energy transfer or transfer of internal energy kan ti thayanga thil te khan particles te hian internal energy, especially heat energy lumna lo ni ta se mo tu yen ye mo fluid at po lumna te lo ma chung te chu internal energy kha mun kha ta tangin mun danga allowing transfer thina mo lumna kha lo pakai thina main chapter danga han transfer of heat kan sei tong khan kha internal energy kha move collisions of particles awang in movement of electrons lo oma an mani khan ti chun mun kha ta tangin mun danga khan conduction, heat conduction or thermal conduction kha lo om thei ta ni chu ting to thermal conduction kan ti ni chu mo. That means it is transfer of internal energy by a microscopic collisions of particles and movement of electrons kan ti khang awang khan thermal conduction om thei kan ti ta ni chu amaro chu thil pakhat kan thriat tur chu thermal conduction kha material zirte temperature zirte temperature difference zirte in thermal conduction kha achakina chaklo theini or the area, so it depends upon different factors. Factor frang abang khan om thina ni chu chuan chu tiang. So the thermal conductivity of the material is the measure of its ability to conduct heat kan ti khania inge kon heat thatka conduct theina material in thatka heat conduct theina a conduct thadlo mo khamiya kha thermal conductivity kan ti chuni tani thermal conduction chu internal energy in transfer khalonia amaro chu transfer thathei lovem ti ability kha athei na kha material frang kha dang vekani chu copper may be different, maybe aluminum may be different. The thermal conductivity of aluminum in comparison to copper may be different, or iron may be different. And low dang cell don ni chu thermal conductivity kha chu thermal conductivity can thei chu ni ta ni chu. So in short, we can say the thermal conductivity of a material is a measure of its ability to conduct heat and transfer thei lo kha thermal conductivity chu niya. And the process, or we can say the transfer of internal energy by microscopic collisions of particles to thermal conduction. Conduction kan ichuna conduct thei chi frang conduct thei the process and ibera amor also conductivity chu athei na kha a potential or at the ability kan ti kha thermal conductivity chunitani. Okay, that is about thermal conduction and thermal conductivity. Okay, thermal conductivity. Okay, now you know that. And now we are going to derive the expression for thermal conductivity or coefficient of thermal conductivity. Okay, so the amount of heat, we must know that the amount of heat flowing through a substance by conduction depends upon a number of factors. Okay, for example, this is a block of iron. Actually, this is a sponge, but you must consider that this is a block of iron or block of aluminum or solid body or metal especially, which are good conductor. Okay, you must think that. So it have two phases here, one phases and other phases. For example, the temperature here is T1 and here is T2. Okay, and here it's have area A, we can say area A, and if we supply temperature, that means T1 higher hot body, or this one will be the cold side, cooler side. Okay, T2. Okay, so the flow of heat is always from the hot body to the cool side. You must know that this way. So from the hot to the cold body. So the amount of heat flowing to a substance by conduction depends upon a number of factors. So you must know that. Or we can say the quantity of heat Q, which flows from the hot phases to the cold phases. So we're going to derive its expression. Number one is, you must know that number one, okay, let's say the amount of heat is Q is amount of heat, Q. Okay, so in number one is the amount of heat which flows from the hot phases to the cold phases directly proportional to the area of the cross section of the phase. This is area of cross section A. Okay, for example, this is a good conductor. It's a metal surface. So if the area is large, that means the amount of flow, the amount of heat flow will be large. If the area is small, the amount of heat flow will be small. So Q is directly proportional to the area. Okay, number one. Equation number one we can write like this. And also the amount of heat flow is directly proportional to the temperature difference. As I have told you, this side is T1, higher temperature, and this side is colder temperature, T2. So it depends upon the temperature difference. So Q number 2, Q is directly proportional to T1 minus T2, number 2. So in some books you may see that they put this hotter side as T2 and the cooler side as T1. There's no problem in putting this value. This here, I mean T1 as a hotter surfaces. Okay, hotter temperature, higher temperature. And third, so also you must know that it is also directly proportional to time. For example, if you heat this body, solid body for a longer period, reisok kan heat and ichon, that means the amount of heat flow will be more, isn't it? Can heat reichon heat flow lo tamang. So it is, the third one is amount of heat flow is directly proportional to temperature, T. Number 3, equation number 3. Okay, so you must know that. And one more thing, there is a thickness here, thickness. If the thickness is smaller, then the amount of heat flow, if the thickness is smaller, but the heat flow will be larger. That means small means quantity of heat will be more. That means it is inverse, isn't it? Inverse. But if it is thicker, that means heat flow will be less, or it will take more duration. So the thickness, how does it depend? It depends inversely. Okay, so amount of heat flow Q is inversely proportional to the thickness. This is equation number 4. So these four factors. So the amount of heat flow or this thermal conductivity depends upon these 4 factors. You must know that 4 factors. Okay, so if we combine these 4 equations, 1, 2, 3, 4 equation, it will come out as like this. So combining the 4 equation is directly proportional to A T1 minus T2 divided by D, and here time also. So we have this equation. Okay, the amount of heat flow is directly proportional to A, difference of temperature, and this time, and inversely proportional to the thickness of the body. Okay, thickness of the body. Or we can write like this: amount of heat flows from one point to another is equal to K. This K is constant. Okay, so constant. Sometimes they put K as capital K also. Sometimes they put lambda also like that. But I will put capital K. Okay, capital K. So what is K? Now we get this equation, very important equation. Amount of heat flow is equal to K A T1 minus T2 and T divided by D. Okay, this is the amount of heat flow from one phases to another phases. Okay, that means if the thickness is more, that means the heat flow will be less, or if the time is more, the duration is more, that means the amount of heat flow will be more. Okay. And now this K, what about this K? So this K is called coefficient of thermal conductivity. Okay, so this K is called the coefficient of thermal conductivity. It is very, very important. Okay, so suppose if the area is 1 unit and the thickness is also 1 unit, maybe 1 centimeter or maybe 1 meter, or the time is 1 and time is maybe 1 second, and temperature difference is maybe only 1 degree. Okay, then from this equation, let's say equation number 5, this is the final equation. From this, if we put everything 1 meter square, or let's say centimeter square, or whatever it be, 1 unit, and this time 1 degree difference, and 1 second, and thickness 1 centimeter or 1 unit, that means everything is 1, that means the amount of heat flow is equal to K, or we can say that K, coefficient of thermal conductivity, is simply Q. Okay, so from this we can define this K. What is K? The definition we can define like this. The coefficient of thermal conductivity is a material may be defined as the quantity of heat energy that flows in a unit time, okay, unit time between the opposite faces of a cube of unit side of that material, the faces being kept at 1 degree temperature difference. Okay, 1 degree difference of temperature only. That means this side and this side, from the hotter region to the colder region, only 1 degree difference. And whereas this, it's unit surface area, and then the thickness also 1 unit. That means that is the amount of heat, okay, amount of heat or the quantity of heat energy that flows from here to here in a unit time. That is the coefficient of thermal conductivity. Okay, you must know that. Heta tranga heat flow unit khatete, the thickness per unit khatnita se unit khatrew heat energy heta tranga degree khatlik difference heta alo kalkhan kha coefficient of thermal conductivity ganti chu alo ni tani. So we can find out what is the thermal conductivity of a good conductor. So there is one way, there is an instrument, or we can say apparatus, called Searles apparatus, S-E-A-R-L-E, Searles apparatus. Searles, we can say. That's a Searles apparatus. Searles apparatus. Okay, with the help of this Searles apparatus, so this K, they used to find out the value of K of a good conductor. Okay, Searles apparatus. So if you look your textbook, you will see the arrangement and the theory of this Searles apparatus, how it is arranged and what is the formula for this K, how to find out, and putting all the values of the formula K, and then you can find out the value of the K for a good conductor. Okay, so now you must know that what is K. This will tell us about the thermal conductivity of a material. It may be iron, it may be aluminum, it may be silver, gold, or copper. So they have a thermal conductivity. So this K will tell us the value of thermal conductivity. Okay, so it is called K, is very, very important. It is called the coefficient of thermal conductivity. Okay, so now we derive about the thermal conductivity, and we talk about the thermal conduction and thermal conductivity. Now you must try to read the textbook also to understand more. Okay, so that's all for today.